Hello, Keatron Evans here. This course is designed to teach you the fundamentals of operating systems. If you don't know what an operating system is, this is the place you need to be. So let's start off and take a look and talk about who this course is for. For people entering the cybersecurity career, definitely for you all. For the people who have already entered cybersecurity but realize you're lacking some fundamentals, for you as well as for people considering entering cybersecurity. People in other industries who need cybersecurity knowledge and those types of things as well, such as auditors. What will we be covering in this course? Well, we will be covering operating system basics, Windows basics, Linux basics, UNIX basics, and Mac OS basics. And this is just an introduction to show you why the operating systems are the way they are, how they evolve, to kind of set you up for us to go deeper when we start talking about Linux command line and Windows command line, which is key for cybersecurity. So what is an operating system actually? Well, it is software that allows us to take advantage of hardware and perform computing operations. This is just one definition. It is essentially the bridge between us humans and the actual computer or CPU, which allows us to process data, save data, manipulate data, send data to other places. The operating system is our primary interface that most of us use to do those things. Windows, let's talk about that operating system first. Windows makes up most of the world's desktop environment. As a matter of fact, 77% of the desktops in the world are running the Windows operating system. Okay. It's also considered to be the easiest to use. Ease of use is one of the reasons Windows gained popularity very quickly over other operating systems when it first came out. Okay. Not a lot of development for the security world. Most of the security world uses variants of Linux as their core operating system. However, there are some exceptions like Commando, which is a Windows VM that FireEye produced specifically for pen testing. Okay. Now, it's a fully featured, complete penetration testing and security auditing custom configured Windows VM. As you'll see when we get to Linux, Kali Linux and Parrot Security are the Linux equivalents to that. One of the things I do want to stop and talk about here, because there's a lot of myths of people coming into the industry that have been told by others that for some reason Windows is more vulnerable than other operating systems. And this is a very common myth. Now, those of us in security, we do understand that part of the reason that you hear about Windows exploits the most, and the reason you see so many Windows exploits in the world, is because of the first number that we showed you on this page, which is that 77% of the world is running Windows right now. So if I'm a hacker or I'm an exploit developer and I want to get the best bang for my buck, doesn't it make sense that I would write my exploit for the operating system that's most deployed? Absolutely does. So a lot of the impetus and why Windows has taken the brunt of the security criticism is largely because of the fact that it was the most heavily distributed operating system in the world. Now, 77% is what it is now. Back in the late 90s, early 2000s, Windows desktops made up 95% of the desktops in the world. And this is when exploit writing and hacking and stuff really started to become mainstream. So a lot of what you hear about Windows being the less secure operating system, some of it's not necessarily true. It's just what it looks like. It's the pictures of that are based on things that we see as far as what we talk about now. And there are some other reasons, but those are some important reasons. So that moves us to the Linux operating system, and we're going to take a little hands-on tour through some of these, all right, in just a minute. But with Linux, it's generally considered to be the OS of choice for security professionals. Now, not every security professional uses Linux as a core, but a lot of us do. Okay. Hundreds of active distributions out there in the world make it a popular choice amongst Linux and security aficionados. And part of this is based on the fact that you can get a flavor of Linux for just about anything that you want to do. Some of the most popular security suites are built on it. For example, Debian is a popular distro in the security world. As a matter of fact, the two most popular security distros or pen testing or cybersecurity distros in the world are Kali Linux and Parrot Security. And both of those are Debian based. Now let's talk about that for just a minute because people are confused about this a lot. If you ask a cybersecurity professional what operating system do they primarily run, a lot of them will tell you Kali Linux. And what they're telling you is not actually true because Kali Linux is not an actual operating system. The operating system is Linux. Okay? The distribution or flavor of Linux is Debian. Kali is just a customly configured version of Debian. All they did was took a Debian Linux OS, installed a bunch of hacking tools on it, and put it out pre-configured and called it Kali. So you have to remember this, and this helps for you to not be so confused, because if you come into the industry thinking that we have Linux, we have Windows, we have Mac OS, and we also have Kali, well, what you're really getting there is Kali's not an actual OS. All right. Now, there's some argument about the next one that's coming up. One of the things that made Linux popular was back in the day, UNIX was the only thing that was out there as far as in the NIX world. At the time, to go and get yourself a good UNIX box and have UNIX running on it, it would cost you about $50,000. And keep in mind, this was the late 80s, early 90s, when $50,000 was a lot of money. I mean, it still is, but compared to now, it's not as much. Well, what happened was the community got tired of having to spend, $50,000 to get a copy of UNIX. And you can go back and look at the dates of when this all transpired. But an individual decided, I'm going to create my own variant of UNIX and make it available to the world, and even make the development of it open to the world. And this distribution that he created was called Linux. Linus Torvalds was his name. He created the Linux operating system, and it literally changed the face of computing. So that's how we got Linux. And then, of course, because Linux is open source, that means that the source code, the actual secret computer code that runs Windows, well, the Linux version of that is open, which means the world can actually download it and see it. So as a result of that, you had people taking the core Linux source code, creating their own variants of it, and coming up with these new distributions. Now we have Debian and Red Hat and Ubuntu and SUSE and all these other different flavors of Linux because of that. But they're all still part of the Linux OS. So I don't want you to think of Debian and Red Hat as OSs, at least not at this level as you're entering the course or entering the market or the cybersecurity community. I want you to just think of all of those as variants of Linux, like they're all Linux distributions. Okay. Now, as if it couldn't get a little more confusing, we move to the next one, Mac OS. Mac OS is actually, initially, it was just a variant of Unix. It was a custom Unix operating system. Now the argument is out that Apple has put so much into building code from scratch to where they're only still variants and they've borrowed pieces of Unix, that it's almost like it's completely own thing now. So Mac OS, or the Mac operating system, is considered to be a separate operating system. And there's a lot of debate about that in the industry. But again, for you coming into the industry, I don't want you to get caught up in that discussion. I just want you to think of it as really we're dealing with three operating systems: Windows, Linux, and Mac OS. Those are the three mains. There are others. So we talked a little bit about the fact that there's something called networking, okay? But there are network operating systems. For example, a lot of the products that you buy on the market out there, whether it be Cisco, Juniper, Extreme Networks, or whoever makes the networking equipment out there, they will oftentimes have in their routers, in their switches, in their network equipment, operating systems designed specifically to run those pieces of networking equipment. And those OSs aren't necessarily Windows or Linux. They're created specifically to run that router. Okay. Now you will find that a lot of the routers on the market actually run Linux as their kernel. So they are running Linux, but some of them aren't. Some of them are running their own OSs made specifically for that router. There's also mobile device operating systems that are specific to some mobile devices. Sure, if we look at iOS, some would argue that the operating system that runs on your iPhone is just a variant of the operating system that runs on your Mac OS. Some of you will argue that if you look at the Android operating system, it is just another variant or another distribution of Linux, which in some parts that's true. All right. But we do have mobile device operating systems, and we also have what we call special purpose operating systems that are created to do a specific thing or run a specific piece of hardware. So we primarily in the entry level of cybersecurity deal with the major three, which is Windows, Linux, and Mac OS. Now, for more content from me on this type of training and other, you can go to this URL. What I want to do right now is let's go and take a little tour. We're going to start with Windows. So what I'm running here is Windows 10. Most of you watching this are probably running Windows 10 because if you go to the store today and buy a computer from, whatever computer store you buy it from, most likely, if you're not getting a MacBook, they're going to sell you a piece of hardware that's running Windows. So this is part of why it still makes up 77% of the desktop. So a couple of things to note is the things that you've probably done the most is you've probably used your browser. In this case, I'm using Edge to go out and visit things on the internet. Okay. So I can do that via this browser. Now, one thing I want you to understand is this browser is not an operating system. This is another area of confusion for people that are coming into the industry. A lot of times you will think that your browser, Chrome or whatever, is an actual operating system, and it's just simply not. Okay. So that's something else that you want to consider and think about as we go into the rest of this. When you compute and use Windows to do things, what ends up happening is you go out, let's say you download a file from somewhere. Well, one of the things that's confusing to people is where that file ended up. We know that most likely it will end up either in documents, which is here, or it could also end up in downloads. And another common place for things to end up when you download them is your desktop. And this is how we generally access that. Now, what I'm giving you here is just a surface level tour, but later we're actually going to do a course for Windows where you're actually going to dig into something called the Windows command line. And that is kind of the under the hood of the operating system that we'll be utilizing. But Windows is a very good very good general purpose operating system that most of you use to do your day-to-day computing. And we can definitely, see its value and how it actually works. Right? Now, there are different things that we can look at for that. As a matter of fact, I want to show you something. It's kind of an interesting here to kind of keep your mind going. When you download a file, a lot of times you will go out and look for that file and you won't be able to see it where you think you downloaded. Sometimes that's because the file may not have actually been downloaded in a format that's proper for how Windows sees file. Also, sometimes if you download a file that's corrupted, you may not see it where you would normally need to see that file. Okay. So this is what Windows looks like. This is how you normally use it. You can control everything from what wireless networks you're connected to. For most of you, you would do that by clicking on the network icon down here, and you can pick your wireless network or see other networks. There's also the control panel. Now you can get there several ways. When you click your start button, over here to the left is the settings button. If you click that, it kind of takes you into a little panel here to where you can control things and modify things. You can also go to search and type in settings there, and it will also bring up that same dialog. Right? So those are some common ways you can actually get to the settings on your machine. Some things that we commonly use it for: gaming. So for example, if I wanted to go and play Xbox games or order games, I could do it right here from my Windows machine. I could change configurations. I could change the network that I'm connected to. I could even do things like change the speeds. Now, later when we get into the security of operating systems, we'll actually look at something called the Windows firewall, and we'll be opening and closing the firewall, right? And that's what that actually looks like. Now, switching gears from Windows, let's go look at another operating system. We're going to look at Linux, right? Now, I'm going to purposely use something called Kali Linux to show you Linux here, all right? So the thing about it is, just like in Windows, there are places you can click, like in applications here, and you can get to, surprise, surprise, different applications to do different things. So even if you've never used Linux before, and every demonstration you've ever seen of Linux starts off like this, which is a command shell or a Linux terminal, it doesn't have to be that way. Different distributions can ease you into the world of Linux without you having to worry about, the terror of being on a command line like this. Now, again, Kali is based on Debian, so this is a Debian distro. But as you can see, we can click our way through and get the things as we need to operate those things. The same way we would open a documents folder or open a folder in Windows, we can do that in Linux, and we have icons of the same. So first off, if you're terrified or you've been terrified of switching or learning Linux, don't be, because it really is this straightforward and easy when you get into the foundational aspects of it. There's really not a ton of difference from the end user experience if you approach it this way. Now, that's not to say it's going to stay that way, because definitely as we get into it more, I'm going to expose you to more advanced things, and you will start to clearly see some key differences and some advantages to using Linux over Windows. But all of the same types of things where you can control your networking, you can find the buttons in here to do that. You can change control places. You can actually browse other networks the same way we would. Things like changing the date and time, all of those things are really accessible to you. Now, I think part of the reason that people are hesitant to learn Linux or move into Linux these days is because once upon a time, it really was a big jump, because there was not these interfaces like this to kind of warm you up to it. But now it's not a huge jump. It's more of a slight horizontal movement over, and you have to relearn some things. But a lot of the mechanisms that you're comfortable with in Windows, you still have access to those, right? So don't freak out about it. Don't let it terrify you. One other thing I want to point out, what I'm going to encourage you to do, and I did this in the intro, is to follow along with me, because later when we jump into Linux, we'll be using the InfoSec skills environment here. And once you get there, once you get your skills account and you get logged in, you'll want to just jump right to cyber ranges. And, we'll be spending a lot of times in the Linux cyber range, and we'll also spend some time in the penetration testing cyber range, because some of the Linux exercises that we do here are going to reinforce in your brain those little weird characters and weird letter combinations that we talked about in the intro course. Well, a lot of that -SS and -H ping and nmap and all that stuff, we're going to use this environment to kind of drive those things into your brain. And I'm going to give you kind of a prescription of where you need to go do these things a few times a week, to where you start to slowly build that up into your brain, to where the command line is not terrifying to you. You actually start to prefer to be there over in a GUI. But having this environment keeps you from having to try to build it and set it up yourself. Now, some people will tell you, and there's some truth to this, that, well, look, part of becoming good at Linux is actually building the environment, because building the environment teaches you things too. And that's true, but that's just like if I said, I want Jeff Gordon to teach me to drive a NASCAR. And if I go to Jeff Gordon's house and he says, well, if you want to learn to drive a NASCAR, first go out there and build one, because you're going to learn a lot of things from building a car. Well, that may be true, but right now I just need to learn how to drive. And then later, as I become a more advanced driver, maybe the mechanics of building a car will help me. And this is some of the most misguided, sometimes unintentionally misguided advice I hear experts giving people that are coming into cybersecurity. Well, go do all these advanced things because you're going to learn things from doing that. True, but let's let them crawl first and then have them walk and eventually run later. Throwing people in the deep end is not always the best approach. And there's a lot of that out there. And I'm not saying that's wrong. I'm just saying that we're here to give you a different approach. We want you to come into it kind of this way. Now, lastly, the last operating system I'll expose you to is the Mac OS, and that is what I'm actually running this course from. As a pen tester, exploit writer, threat hunter, incident response person, Mac OS is my core operating system. And a lot of people ask me why that is, because you just said that most people use Linux. Well, guess what? Mac is primarily, a lot of it under the hood is still Linux. So for example, let's just make this a little bit bigger here. These commands like ls, ifconfig, pwd, these are all Unix, Linux commands. So even though this is its own operating system, a lot of the commands and a lot of the structure was borrowed from the Unix and Linux world, because as I said in the beginning, the impetus, the beginning of Mac OS was actually a Unix variant, a combination of Unix things. So all of the commands, and this is what you'll find useful, a lot of the commands that you learn when you master Linux will transfer nicely to your Mac if you start using the terminal. So the main reason I use a Mac is at one point in time, my primary job was to write exploits. And my focus and my mission team, we focused on writing browser exploits. So I needed to, on a monthly basis, we needed to produce exploits that would successfully take over a machine running Chrome, running Internet Explorer, running Firefox, and Safari, the main browsers out there. Well, the only way I could have a accurate representation of someone running a MacBook, a Linux machine, and a Windows machine is to have a MacBook as my main host, because you can't really virtualize Mac OS and it be the same as on a physical MacBook. One of the operating system foundational things that they never tell you about is when you build a Windows machine, or when you go buy a Windows machine, that hardware can run a million other different things. When you buy a Linux machine or you build a Linux machine, that hardware can run a million other things. But for a MacBook, this hardware was designed specifically to run the Mac operating system. So the operating system to hardware integration is something that you won't see in the other two. So there's advantages to that and there's disadvantages. But for me, I can write an exploit and test it against Chrome on Windows, Chrome on Linux, and Chrome on Mac OS, all within this one physical box that I'm running this class from. So what I mean by that virtual machine is we're looking at a full out MacBook here. This is my Mac operating system, and this is a Mac interface that you're looking at. But very quickly, I could change screens. I could do this, and then what I'm bringing up is now this is a full out Windows machine, except it's a virtual machine, but it's Windows. So I can test the exploit against Chrome here. And then when I'm done with that, I can jump right out, go over to my Linux distribution, which in this case is Kali, which is a variant of Debian. Okay. I could now test the Chrome exploit on this machine, and I can do all that with one physical box. Whereas if I had a Windows machine, I could virtualize Linux, but I have to have separately a physical Mac machine to accurately test those exploits. So that's my primary reasoning for why I switched to Mac over 10 years ago. And I still don't regret that decision. There's a lot of advantages to, I think, to this operating system. Right now, I've got about 13 virtual machines running on here. And if you notice, there's really no lag in the performance. And I've only got about 16 gigs of RAM running here. It's not like I built a super machine. Part of that's because of the hardware integration and how well it actually works and adapts to those things. So just kind of to give you a little bit of review here, the operating system, when you sit down to your computer, the very first thing that you do is interact with your operating system. When you turn the power on, it actually boots up your operating system. When you're running your browser, let's say we're over here doing this, all of this is happening on top of the actual operating system. When you run Word, if I were to go and open a Word document, okay, I'm running that on top of my operating system. Here's a PDF that deals with APT1, which is essentially a hacking group that we've been tracking in the world for a lot of years. This white paper that Mandiant wrote some years ago gives you details of APT1. All right, so again, let's not get it confused, because I know some of you are entry level and you get confused by this. We're opening this PDF in a browser, right? We're opened it in Internet Explorer, or what do they call it? Edge here, Microsoft Edge. But you can also open a PDF with a Adobe PDF reader. But see, the browser that we're running in, Edge here, is still just an application that runs on top of the operating system. If I were to open this PDF in Adobe, then now I would be reading it in Adobe, but that's still an application that runs on top of the operating system. If I were to open something like Notepad, and then I were to type a message, well, Notepad is just an application that runs on top of the operating system. So what I really want you to get in your head is everything I just did here with Notepad, with Edge, with the other tools that we had open, this all happened on top of the Windows operating system. Now, we can do all those same things in the other operating systems, but just kind of get in your head what the operating system is. And then that whole thing that we talked about, where we had security and all that, remember, as I show you Microsoft Paint here, and by the way, a lot of people call me a cybersecurity expert, but I'm going to tell you guys a secret. What I'm actually an expert in is Microsoft Paint. This is my expertise. This is what I got my degree in. And you're going to see some pretty exquisite, stunning artwork here with my paint skills. But essentially, remember, you have your operating system. So let's just call that OS. All right, so just to get you prepared for the industry, you will also hear people just say OS. So when they say OS, they're meaning Mac, Windows, or Linux. Just think of it that way for now. So we have our operating system, and then on that operating system, we have data. And then we might have another machine or another server somewhere else in the world. Guess what? That server also is running an operating system. And then if we wanted to get this data from this machine to this one, then we would have to go across, a router. Well, guess what? That router, guess what it runs? It still has an operating system. So now as our data makes its way from here across this router to the other side of the world, to this server, it still had to traverse several operating systems. Let's just say web server here. So one of the things that we're going to dig into is, again, as this data moves from place to place, it still has to be protected. And one of the core things that we have to really lock down and secure and protect to protect our data is the operating system, because no matter where your data moves, it's probably interacting with an operating system at each point along its path to wherever it's going. So we have to think about that. And when we think about securing it, the operating system is one of the main places that we have to focus our security. And we have an entire sects and entire divisions of cybersecurity focused on nothing but operating system security. Now, as you can probably imagine, I might have, or as you see now clearly, I might have exaggerated my Microsoft Paint skills a little bit. But you kind of get the point here. Operating systems are really, really important when it comes to the security of your data, because if you don't have an operating system, 99% of the world don't even know how to access data or interact with our data without an operating system. You can't call your friends without an operating system because your mobile device runs an operating system. You can't browse the internet without an operating system because your browser runs on top of an operating system. And most of us now, believe it or not, we can't even drive our cars without an operating system because most of our cars now come with an operating system. Now, obviously, Tesla and others have taken that to a whole new level, but there's little operating systems that run most of the things in modern cars now. And there's a huge, huge reason for us to be able to secure that. So the main purpose of this course was to make sure that you understood exactly in your mind what an operating system actually is, and you don't get it blurred with other things, because when we talk about securing applications, that's different than securing operating systems. Applications are just things that run on top of operating systems, right? So hopefully this helped you to kind of understand the three main ones: Windows, Linux, Mac OS. I know you're going to hear a lot of other things. Just stick with those three for now as we build your skill set out. And hopefully this will make you a little bit more comfortable as we move into some of the other topics. So looking forward to seeing you in the next module, which is going to be us taking a course and going through it in Windows command line. And we will be doing mostly hands-on. So get ready to jump right into that. Thank you for watching. Hope you enjoyed it.